Namaste. Namaste. I, JVM, Narendra Kumar Jha, Assistant Professor in Department of Science and Technology and Faculty of Education and Methodology, Jyoti Vidyapith, Women's University, Jaipur. So we are going to discuss about the data encryption standard today. So this is in the block cipher. So what is data encryption standard? Firstly, when we talk about this, so it is a block cipher process where a block cipher processes plain text input in fixed size blocks and product a block of cipher text of equal size of each plain text block. Just like I'm taking a 8-bit plain text here, so this will generate a block of 8-bit and then also generate the cipher text of 8 bits only. So here two users share the same encryption key. We can say this is there will be a common key. So here we can see when a plain text when we take a b bits plain text here and then we are applying any encryption algorithm by using a key k, then it will generate a cipher text of the same b bits. Now when it is sent to the receiver, so I'm saying this is the sender here and this is the receiver send. So when we see b bits of ciphertext received here at the end of the receiver, and then by applying the same key k, the decryption algorithm is applied, performed, and then it will be converted to plain text. So the plain text will come of b bits here. So the same bits will be in the plain text and ciphertext while using the block ciphers. So when we talk about the DES, so it was issued in 1977 as Federal Information Processing Standard. We say FIPS. So this is the standard, 46 standard by the NIST. So this is the National Institute of Standards and Technology, where all the standards are issued and the terms which are related to these also defined there. So now coming back to the DES encryption. So data are encrypted in 64-bit blocks by using 56-bit of key. So the key size is 56 here, but the sub key size will be 48 bits here. You will see in the later slides that how a sub key is generated and why we generate a sub key here. Why don't we use a key which is 56 bit? So there is a 64-bit block. So it is definitely we are using the 64-bit block here. Then the algorithm transforms 64-bit input in a series of steps into 64-bit output. So there will be number of steps where a plain text, we simply see and that this is the 64-bit, we divide into 32 to 32, and then some mathematical operations are applied here, and then the key is applied here. So these are the things we will see in the next slides. So in the next slide, we'll see. So there are the two inputs to the encryption function: a plain text and to be encrypted and the key. So first one is plain text, and second one is the key. So in the DES, there are two algorithms that run parallelly, which is the first one is to encrypt this text, and the second one is to generate sub keys here. So the function expects a 64 bit key, out of which 56 are used, and 8 bits can be set arbitrarily. So where we see a 64-bit block is there. So why do we use 56 only? So there are 8 bits that set to be arbitrarily, and they are not used here. That's why we use the 56 bits of key. Now, plain text processes in 3 phases. How it is processed? First, the plain text passes through an initial permutation, that we say IP, that rearranges the bits to produce the permuted input. So this the initial permutation is done just like how we do the initial permutation. It's like I have a text DEL, so I change the order of these. So this will become E, D, and S. So this is the permutation here. Now, when we talk about the second phase, so it consists of 16 routes of the same function, which involves both permutation and substitution function. So what is the substitution? Just like we are having a 64-bit text here, and we are dividing it into two, that is 32. And what is the key size? What will be the key size here? If I am applying 32-bit, and also here will be 32-bit, here will be 32-bit, then I'm also applying the key, which is the 48-bit. So how 32-bit will be the 48-bit? So I'm just expanding this first. So this will be the 48. So I need to substitute again to the 32. So this operation will be performed here. 42 to 32 bits. So this operation is performed here. So the number of rounds depend on the key sub keys. So there will be the 16 rounds in the DES. So it is fixed. Now the output of the last round consists of 64 bits that are the function input and plain text, that are the function of the input plain text and the key. So how it is, how it works? Just like I said, the 32 bits in the left and 32 bits in the right. So these will make the 64 bits at the end. So all the permutations and expansion or substitution, these are the mathematical functions that are applied here. After that, what we do, we substitute that, and we come to the conclusion that only 64 bits will be here. When we see the left and right half of the output are swapped to produce the pre-output, just like I said, the first 64 bits are here. So these are swapped. When we say the process left bits are XORed with the right one are swapped with each other. So this is the process. Process left bits. Here is a function. This value is used in the function, and the key is applied here. The key is applied here. So the right bits, right 32 bits are processed with a mathematical function, and these right bits, these are left bits. So left processed bits are uh, XORed with the right bits. So these are the right bits. So these are processed and swapped with each other. So they are back again here. So 32-bit will be here and 32-bit will be here. But these are processed. Just like right one is the here and the left one are the here. So finally, pre-output passes through a permutation, that is the inverse of the initial permutation function, to produce the 64-bit ciphertext. It's like we have discussed the 3 steps. So we will just do the reverse of the second step, and then we will perform the final output here. Now we talk about the subkey generation. So first of all, the key is passed through a permutation function where 56 bits to it is first the initial permutation is done, and after that it is divided into rounds. So this will be substituted to 48 bits. So in the permutation, these all the bits are shuffled with each other, and after that the first 48 bits are selected, and this will be the first key. And then we again take this to generate our second subkey. Then we take this to third subkey. So the permutation is done in the every step, and then we just select the 48 bits of the key. So there will be 16 rounds. So for the 16 rounds, sub-keys are produced by the combination of left circular shift and a permutation. So these are two things. What is the left circular shift? Just like I have a keyword, just like a DES. So what is the left circular shift? I have to shift all the bits to left, just one place left. And what is the leftmost? D. So D will be moved at the end. So what will be the ES D? So E1 and 2 and 3. So we are moving place 2 to 1 and 3 to 2 and 1 to 3. Why we are doing this? This we are applying the circular shift. So we are just doing this thing and a permutation. So I told about the permutation earlier. Now the permutation function is it's same for each round, but a different subkey is produced because of the repeated shift to the key bits. Just like I'm shuffling a text, just like beat. So I'm just changing the first place to third, second as it is, fourth one to first, and third one to fourth. So what is the key? 4, 2, 1, and 3. So the same process will be done in every step. It's like what I got right now. I got the T, E, B, A. So this is T, E, B, A. Now I will apply the same. It will go to the third place. It will remain the same. Last one will be the first, and we will be the third one will be the last. So this process is always same, but the shift makes a difference. Just like I will do the circular left circular shift. So now the output will be EBAT because the T will be placed here. Now the same permutation will be applied. So in each round the key will be different. Now when we see the working of DES, so this is the initial permutation of 64 bits. Here a 64-bit key, it's 56. Yeah. So the permutation choice is taken here. The 56 bit, the left circular shift is applied and the permutation choice is applied, and then the 48 bit is selected. So what is in the round? So in the round, is 32 bit of the key of the plain text is taken, and then it is expanded and then processed with the key, and then it is substituted back. So this process, this is the key generation algorithm, and here this is the encryption. So these are two algorithms work simultaneously. Now we can see after the round 16, 32-bit swap is performed here, and the initial permutation is performed, and then we got the 64-bit ciphertext here. Now, what is the DES decryption? So it uses the same algorithm as the encryption. This is vice versa of the algorithm here. So except the application of subkeys is reversed. So how we reverse the subkeys? So this is the difficult task. But we do decrypt by using the same processor or the same subkeys available there. Also, the initial and the final permutations are reversed. Now, why we are reversing the initial permutation? just because if we want to decrypt the uh, ciphertext to the plain text, so we need a key. So the key will be used here. Now, what are the concerns? So this algorithm itself refers to the possibility that cryptanalysis is possible by exploiting the characters of the algorithm. Just like there are some limited functions, mathematical functions which are used in the DES. So how this will be working in the condition of how long it is possible to the hold. So when we talk about this, so DS was finally proved insecure in 1998. So this is the thing. Still, then the AES came in the picture, and then other versions of that. So that is using a larger key, 128 bit key. Now, when we use a 56 bit of key, so there will be this much of keys, 7.2 multiplied by 10 raised to the 16 keys. So this will be done in the 1/4 years. It will take just 16 months to crack this encryption if a standard PC is working there. So the time required PC, which is decrypts 10 raised to power 13 per second. So this will be simply cracked in an hour. So this was proved insecure in 1998, and who broke this? So Electronic Frontier Foundation (EFF) have broken using a machine that took less than 3 days. So in the less than 3 days, the Electronic Frontier Foundation cracked this DES. So this was all about the DES. Now in the next sessions we will discuss about the 2 DES and the 3 DES, and more about the key generation, and we'll discuss about what is inside the 16 rounds, what is in the a single round out there. So thank you.